Okay, so there's no new equations in this video. It's just some new applications of the equations we've already been working with. The key to any conservation of energy problem is remembering these two things. First off, mechanical energy, or your total energy, is always equal to KE plus PE. All right. The other thing is always remembering that at the top, ME equals K equals PE. At the very bottom, ME is only equal to KE, because the other one is 0 at that point. All right, which you could rewrite this, and this will kind of come in handy if you follow along with this. Top PE is always equal to the bottom KE. All right, so you'll see with the next question, you'll understand why that's kind of important. So, certain types of conservation of energy problems do not require you to know the mass. And if you remember from the skater worksheet, mass, there was something mass didn't have an effect on. Okay, which means if you're solving for that, you can actually cancel out the mass from your equations. And I'm going to show you how to do that. So here we have a ball that is dropped from 30 meters high. What is the velocity of the ball just as it hits the ground? So we know that h is 30 meters. We know that g is going to be 10 meters per second squared, right? And v is our question mark. So you should also, just based on our knowns, see that we have a little bit of PE and we have a little bit of KE. We also know information about the very top, and then it's wondering what the velocity is at the bottom. So your equation in this case is setting your things equal to each other, because PE at the top is equal to KE at the bottom. So mgh equals 1/2 mv squared. Now if you start rearranging this, because what we're trying to find is velocity, so if you start rearranging it to get v by itself, you start by multiplying by 2 on both sides to get the 1/2 out of there. So we have 2 mgh, and this is going to cancel out, equals mv squared. Your next movement would be moving the m. You'll notice that cancels out on both sides. Hence, you don't need mass. So now we're down to 2gh is equal to v squared. So to solve for v, you just take the square root of both sides, and your equation is b equals the square root of 2gh. So let's finish this. If we go to solve, we'll have v is equal to 2 times 10 times 30. Okay? Which is going to be the square root of 600, or 24.49 meters per second. Okay? So this is a very special case. You can also use this in a reverse sense. Say you're given the velocity you throw something up with, and you want to find maximum height. Again, you'd be setting PE equal to KE, and the m's would cancel out. So another way you may see these problems is, instead of being given height, you know enough to find KE at the very bottom, which then will give you ME, which then will give you PE. So let's walk ourselves through one of those. We have a 3 kilogram ball that you're throwing into the air. When it leaves your hand, which we're determining your hand height to be 0 height, you measure a speed of 9 meters per second. Okay, and the question is, what is the kinetic energy? So if we do this, we know M is 3 kilograms. We know V is 9 meters per second. And our equation is going to be KE equals 1/2 mv squared. If we substitute in our knowns, KE is equal to 1/2 times 3 times 9 squared, right? Which becomes 81 times 3 divided by 2, or 121.5. Your units will be joules. Okay? So that's first part of this problem. So now we found KE. Now let's answer a couple more questions. What's your potential energy? And again, this is going to be at that same position. Hopefully you're noticing that since height is at 0, and to find PE, you've got the H in there, and if you plug a 0 in there, PE is going to be 0. All right? And then here, ME is always equal to KE plus PE. So if KE is 121.5 joules and PE is 0, that's going to be 121.5 joules. Okay, so let's add one more question to this. Now that we know KE at the bottom was 121.5 joules, ME will always be 121.5 joules. Question is, what is the maximum height of the ball? Okay, so we know PE equals mgh. And before I jump too far ahead of myself, we do still know that our mass is 3 kilograms. And then, of course, we know G is 10 meters per second squared. And then, what's unique about the maximum height, the top place for a conservation of energy problem? We know that PE is equal to ME, or it's 121.5 joules. Okay? So if we, let's see, I'm not ready for this yet. If we are wanting to find the maximum height, we can rearrange our PE equation for H. So it's going to be H is equal to PE for mg, and then substitute in our knowns. We know PE is 121.5 over 3 times 10, or 121.5 divided by 30, which is going to be 4.05, and since we're solving for height, units are meters. Okay, this is just a couple of examples of more, not even necessarily more difficult, but less commonly thought of problems. Okay, so it's a different approach than what we've had before, but as long as you stay true to the fact that ME is always equal to KE plus PE everywhere, and that at the very, very top of a situation, everything is potential energy, and at the very, very bottom, everything is kinetic energy, conservation of energy problems really aren't that hard. Okay? So have your notes in class, and make sure you do the online form. See you in class.